Hello viewers, today now I am going to discuss about the introductions to data flow analysis. Before going to discuss about this particular data flow analysis, now I am going to explain about the optimization. This particular optimization is produce a efficiency of our target program or target code. The optimization is the following types. One is the local optimization, loop optimization and global optimization. The local optimization is there are different kind of local optimization techniques are there. Those are the common sub-expression eliminations, dead code eliminations, copy propagation and constant folding. These are all under the local optimization. Next one is the loop optimization. The loop optimization is code motion and reductions in strength and etc. These are all the loop optimization techniques. Next one is the global optimization. This particular global optimization is actually performed on the data flow analysis. Any particular variables are declared within the main block is called the local variables, or any particular variables are declared outside of the main function is called the global variables. So these particular global variables scope and lifetime is throughout the program. So whereas in the local variables that particular scope and lifetime is within that particular block only. So this particular global optimization technique, the scope is the broad scope. So means here which a variable retains its value throughout the program is called a scope, and lifetime is nothing but what part of a program a variable is actually available for use, that is called the lifetime. So in our global optimization technique, in this particular global optimization, a fundamental unit is called a flow graph is used on which the global optimizations can be performed. So now we analyze the flow and data moving through the flow graphs by using the data flow analysis. So in this particular data flow analysis, what is mean by here the flow graph? The flow graph is nothing but there are different nodes plus edges. So the flow graph is nothing but the set of nodes and edges. So these particular nodes are represented in the form of basic blocks, and edges is represented in the form of control flow. So what is mean by basic block? The basic block is a sequence of consecutive statements in which the flow control enter at the beginning and leave at the end without any halt. That is called the basic blocks. In this particular basic block here, there are sequence of consecutive statements which flow control enter at the beginning and only single entry point and exit at the end point without any halt. So now next here, these particular some terminologies is used in the basic blocks. One is the define and use. So in this, what is the define and use? So in our three address code statement here, A is equals to B plus C. Here define A and to use B and C. These B and C are to use for define A. This is called the define and use. Next one is the live and dead statements. The live statement is nothing but what part of a program a variable is actually available for use, that is called the live or live variable, and what part of a program a variable is actually not available for the use, that is called the dead. Next here, why we know about this particular data flow analysis is nothing but in this particular data flow analysis it is determine the useless statements. It is determine the useless statements. And also in this particular data flow analysis is determine the constant propagation. That particular constant propagation is eliminate the constant propagations. So that is why it improve the code efficiency. So now here in this particular data flow analysis, I will take some set of statements here. Now y is equals to 5, and x is equals to y plus 2, and again x is equals to y plus 1, and z is equals to x plus y. So in this set of statements, this set of statement sequence of consecutive statements, this set of in this case what happened here, the flow control is here. First of all, here y is equals to 5 and x is equals to y plus 2, again x is equals to y plus 1, and z is equals to x plus y. So this is one particular basic block, and this is another basic block, and this is also one more basic block. These are the set of different kind of basic blocks. So here the flow control is enter at the beginning, and leave at the end without any halt. So after completion of this particular block B1, and it is enter into the another block, and after completion of this particular B2 block, again enter into the another block B3 and B4. Finally it is exit at the end. So this is called the flow or flow control. So this particular flow control is based on this particular some constraints. So in this particular case, what happened, without there is no any constraints. So some other case, what happened here, suppose x is equals to 4 and c greater than 0. In this particular block, what happened here, based on this particular constraint, if this particular constraint is false or constraint is true, there are two paths. If this particular constraint is true, what happened here, suppose y is equals to 6, let us assume, and x is equals to 7. Next here, if this particular false case, what happened, I want to y is equals to initialize as a 0. There is no any update in the x. So in this case, what happened, now I want to use this particular q is equals to x plus y. So in this case what happened, in this particular flow control is based on this particular constant. If this particular constant is true, at that time what happened, it will go to update initialize this particular y value, and again update this particular x value. X value is 7. Initially x value is 4, but here updated x value is 7. So this particular, after completion of this block, then again the flow control goes to this location. Now this particular expressions q is equals to x plus y, at that time this x not reach to this particular block. So here the x value is 7 plus and 6. So the resultant value is stored into the q location. So what happened in the false case? In this particular false case only it is initialized to 0. At that time, in this case, what happened in the false case, whenever if it is take the false case, so it's take the initialized value 4 is available in this particular x location, available in the x content, and y value is initialized to 0. So that is why here the resultant value is only 4. So this is the case. This is called the flow controls. So now in this particular some other terminologies already I explain about this define and use and live and dead. So this that is why we know about the data flow analysis is nothing but here it is determine the useless statements. It is determine the useless statement. And the next one is here it is determine the constant propagation and eliminate that particular constant propagations. Suppose here In this case, what happened in the data flow analysis? What happened? Suppose x is equals to 5, x is equals to 5, and x is equals to y plus 2. So that is why y value is 5 plus 2. Total x value is here in the 7 in the second statement. So what about x value here? The x value is already 5. 5 plus 1 is 6. So next one is z is equals to x plus z. So x plus z, x plus y. So in the recent evaluated x value is 6. That is why it is involved in this particular expression 6, and y value is 5. So totally z value is 11. Total z value is 11. So that's why this particular statement, this kind of statement is not required. So this kind of statement is determine this particular useless statement. Determine this particular useless statement, and it is avoid that or eliminate that kind of statements. So that is why we learn about this particular data flow analysis. Now in this now I am going to explain about how the constant propagation. So in this particular constant propagation, what happened? Now y is equals to 5. Next p is equals to y plus any particular variable 2. Now q is equals to y plus p. So suppose these are the some set of statements. In this set of statements, main thing is here it is the constant propagation and dead code elimination. So in this case, the constant propagation is here. Suppose in the constant propagation Cp, y is equals to 5 and p is equals to y plus 2 and q is equals to 5 plus p. So in this case, what happened? This particular constant value I substitute in this particular y location. So suppose here also you may submit that particular y locations. In this case, what happened? If you substitute this particular directly constant value into the expressions, at that time no need to use this kind of statements. So that is why here the eliminate the dead code eliminations. Now dead code elimination. So this kind of statement is totally eliminate here. Generally here p is equals to 5 plus t and q is equals to again 5 plus p. So that is why what happened, these kind of statements are improve the efficiency of our target program. That is why we learn about this particular data flow analysis. So in this particular data flow analysis, they particular algorithm partitioning into the particular basic blocks. So in this particular basic blocks, if you want to partition a particular basic blocks, here there are some certain rules are there. Those rules are here. First determine the leaders. By using the following rules. What are the rules here? There are three different rules are there. The first one is the first statement. Very first statement is a leader. So in this particular set of sequence of consecutive statements, this first statement is called a leader. The next one is any target statement of conditional or unconditional go to is a leader. So in the go to statement, that particular target statement is a leader in conditional or unconditional. This is the second rule. And the third rule is any statement that immediately follow a go-to. Any statement that immediately follow a go-to is called a leader. Is called a leader. So after determining these particular leaders, then go for form a basic blocks. That is the step 2. In the step 2, what happened? The basic block is a formed starting at the leader, statement. Next, end just before the next leader. End with just before the next leader. So by using this particular rule, you can form a basic blocks. So now I will take some example for this particular constructions of the basic blocks and flow control. Please observe here. I want to take some pseudocode or some particular code in C programming language for computing the productions of two vectors. So here I want to take a particular C programming code. Suppose here product is equals to 0. Now I is equals to 1. Next do. Here product is equals to product plus a of I subscript value into b of I. These two subscript product is I want to evaluate here. So next I is equals to I plus 1. So the next statement is while here I less than or equals to 10. So in this case what happened? The initial value is 1. So this loop is repeat up to 1 to 10 times. So that particular these two vectors are product of these two vectors I want to calculate here. So for this particular code, now I want to write down the 3 address code for this particular set of statements. So in the 3 address codes are here statement 1 product is equals to 0 and statement 2 I is equals to 1 and statement 3 T1 is equals to I into 4. So for any in this particular subscript value is a integer type. If it is integer type, integer memory occupations, it is a 4 byte of memory in this discussion. So that is why for any counter variable it is occupy the 4 bytes of memory. So next one is after evaluating this one, next fourth statement T2 is equals to A of T1. Next fifth statement here T3 is equals to again I into 4 for B subscript value. Next sixth statement T4 is equals to B of T3. Next seventh statement T5 is equals to T2 into T4. So this is the T1 and this is called this is called the T2 and this is called the T4. So these two values are product here again updated into T5 location. Next again here eighth statement. So T6 is equals to product. T6 is equals to product plus T5. So next after completion of this particular product and this product of these particular two vectors, then resultant these total sub expressions evaluation is pushed down into the product locations. So that is why here in the ninth statement here product is equals to T6. Then after completion of this one, next go for this one. Next 10th statement here. Now T7 is equals to I plus 1. Next 11th statement, T8 is equals to I is equals to T7. I is equals to T7. After completion of this particular I plus 1, that I plus 1 is evaluated, stored into the T7 location. Then this T7 is pushed into the ith content. Next, after completion of this one, go for the test condition here. Suppose 12, if I less than or equals to 10, then go to step number 3. So in this case, what happened here? These are all the some 3 address code statements for this particular C programming. So after conversion of this particular C programming, then go for partitioning into the basic blocks. So if you want to partitioning into the basic blocks, then you have to follow these particular rules. So the first rule is, the first statement is a leader, to identify the leader first. So this is called a leader according to rule 1. According to rule 1. So according to rule 1 and 1A, according to, this is called a leader according to 1A. So this is called a 1A. The first statement is a leader. The next, any target statement of conditional or unconditional goto is a leader. So this is called, is there any particular goto statement, conditional or unconditional statement? Here we have a particular statement. If I less than or equals to 10, if this particular condition is true, then go to statement number 3. So that is why go to statement is a leader. So the flow control is directly go to this location, from this locations to this location. So that is why this is called a leader. So that is the 1B. The rule number is 1B. Rule number is 1B. Is there any other statement is leader? You have to identify here. So there is no any leaders. So if any statement that immediately follow a go to or unconditional go to is a leader. If there is any some other statements in this case, in here, suppose 13, 14, 15, at that time, after completion of this particular go to statement, immediately follow the next statement is also a leader. So that's why according to this particular code, so these are all the 3 address codes. There is no any leaders. So after completion of the leader identification, next go for form a basic blocks for basic blocks. So the how to form a basic blocks, starting at the leader statement. So this is the leader statement, and ending just before the next leader. So that is why here. So this is called a particular starting to just before the next leader. We have to form. This is called a block 1. Okay. The next one is the starting from this particular leader and up to here. This is called another block. So this is called the block 2. So according to this particular rule, so rule 2, you have to follow this particular basic block is formed. So after that, then here the flow control. Now I am going to explain about the flow control. After completion of this particular block 1 statements evaluation, the flow control goes to the next block. Flow control goes to the next block. So after completion of these total blocks, then again flow control is goes to same block. So means that is the block 2. So that is why here the flow control is goes to itself, B2 statements only. So if this particular condition is true case, if is the true case. If this particular condition is false, what happen? If it is, this is called the exit. So in the data flow analysis, what happened? The data flow analysis gather the informations from our source program, and that particular information is distributed to our different blocks. So this is called the data flow analysis and flow control and basic blocks. Flow control and basic blocks. Thank you.